Good evening, everybody. Today, we have Abdul Pinjari. Abdul Rawoof Pinjari is a professor in the Department of Civil Engineering and the Center for Infrastructure, Sustainable Transportation and Urban Planning at the Indian Institute of Science. His research is on modeling human choice behavior in transportation systems with applications in human mobility and travel behavior analysis, demand forecasting, public transportation system, and land use transport interactions. He is currently leading the development of city-scale travel demand modeling tools for Indian cities, which can be used to evaluate various transportation projects and solutions being considered for the cities. He is also working on understanding and modeling travel behavior in complex environments characterized by a multitude of travel options with different levels of uncertainty and information availability. Thank you so much, Abdul, for coming here today. Over to you.
Thank you, Devika. It's the first time I'm also here at Science Gallery Bengaluru. I've been wanting to visit Science Gallery Bengaluru as a visitor for quite some time. I've heard many wonderful things about the place. Looking forward to actually going around after the talk. So what I'm going to do today is to highlight the importance of studying travel behavior, and then through that modeling transport systems of a city to understand how to manage transport systems in a city and how to hopefully to some extent address the transportation problems cities are facing. So as Devika was mentioning, I am a faculty in civil engineering as well as a research center called CISTUP, Center for Infrastructure, Sustainable Transportation and Urban Planning at IISc. Let's briefly talk about the center. It's a center for multidisciplinary work which includes research, education, and technology transfers in multimodal transportation science. I'm highlighting the word multimodal, which I'll talk about soon, engineering and technology, and then all of this towards sustainability in transport systems and urban planning and so on. We do this, of course, through creation of scientific knowledge, technology solutions, education, as well as training, and then collaboration with governments, industry and academic institutions and so on. Just to give an idea of the various types of research that's conducted by many of my colleagues and our students and researchers at the center, what's inside the circle are the various topic areas such as public transit. I'm going to talk a lot about public transit today. Walk, bicycle, last mile, first mile, shared mobility, ride hailing, and so on. Electric vehicles, freight and logistics, safety. All of these are topic areas. What many of my colleagues and many of our students try to do is bring to bear their methods that's around the circle, right? Networks, engineering and safety, sensing and measurement, behavior and psychology, decision sciences, demand forecasting, materials, and so on. All of these methods are sort of brought to bear to address these topical questions. All of this toward larger goals such as sustainability, sustainable development, SDGs, smart cities, improving transport planning, better cities, better air quality, equity in all of these things, so to say. So hopefully this gives an idea of what many of my colleagues, not only at CISTUP, not only at IISc, many of us in the transportation field try to do. The whole community of transportation researchers, practitioners, and so on, try to do some of these things toward better cities, toward not only better cities, toward better connectivity between cities and so on. Right? This is just a glimpse of what many of us in the community try to do. With that, I'll switch back to the topic that I'm here for. Right? The topic I'm here for is why do we need to study travel behavior to model and manage our cities' transport systems? Right? So now let's think about what is travel behavior, right? What is travel behavior? I traveled here today. I walked from my residence to the nearest bus stop. I couldn't find the bus on time, so I took an auto and came. Many of you may have traveled on your vehicles. Many of you may have come buses. Maybe some of you walked and so on. So that is one aspect of travel behavior, right? The mode of travel we chose to travel by. That one aspect has a substantial impact on our city's transport systems, right? For example, the current mode share of transit systems, public transit, bus, rail, metro rail, and so on in the city in Bangalore is anywhere, depending on what data we look at and so on, anywhere from 30% maybe to 45% or something, right? We don't have a clear-cut idea, but it's this range, right? There's a lot of other modes used, personal vehicles, two-wheelers, cars, Olas, Ubers, and so on, right? If we can do something in our cities to shift to, not fully, at least to a good, small extent, people from their own personal vehicles to public transit modes of travel or other modes of travel, right? Such as non-motorized modes and so on, that itself can help reduce a lot of transportation problems we face, right? Congestion, pollution, and so on and so forth. Just one aspect of travel behavior, right? There are many other aspects, right? For example, you can think of it as where people travel, where goods move, right? The destination choice, right? Today, all of us chose to come here. The destination of our travel today, or at least one trip today, is Science Gallery Bengaluru, right? When people travel, why they travel? People travel for, let's say, livelihood, education, socialization, recreation, and so on. How they travel, the mode of travel, the route of travel, right? And how much they travel, right? And it's not only travel by people, but also the movement of goods, right? All of this is essentially manifestation of all of this, right? You can think of it as travel behavior, right? Most of it depends on, first of all, what we do in a day, our activities in a day, right? At least when it comes to passenger travel, right? We go to work, we go for shop, we go for recreation, we go to meet people, and so on. And then for these activities, we make choices of how do we travel, where do we travel, when do we travel, with whom do we travel, which route do we take, all of that, right? The route do we take and all of that, right? Of course, it's individuals who make choices, but aggregation of all of these choices, right, is what results in the overall travel patterns in the city. From where to where is more travel, which routes are congested, where is it, which modes is it easy to travel by, and so on, right? When do we see congestion, all of that. So, in a glimpse, this hopefully gives an idea of what travel behavior is. And of course, travel is not only within the city, although we are worried about a city, let's say Bangalore. A lot of travel happens into the city and out of the city as well. We can't separate a transport system and isolate it from the rest of the world, so to say. We need to consider travel across the border also. And then all of this together of all of us, right, in the city, right? If you aggregate it all, where each of us travel in the city, when each of us travel, by what modes each of us travel, by what routes each of us travel, not just us as people, but goods move and so on, right? In what shipments, in what modes they move and all of that, right? That leads to travel demand. It's an aggregate manifestation of the travel behavior, so to say, right? That leads to travel demand, right? And it's this travel demand that leads to usage of transportation services and facilities, transport infrastructure, right? Roads, buses, air terminals, rail terminals, bus stands, all of this, all these facilities, right? And this is what leads to ridership in buses, metro systems, usage of shared mobility, all of that, usage, right? This is what the demand is, what leads to all of this. And then of course, this is what leads to the traffic we see on roads at signals, right? And this is what also influences the performance of a transport system of a city, right? In the form of the time it takes to travel, right? If there is heavy congestion, then travel gets slowed down. It's not uncommon, or it's quite common in our city, for example, that what would otherwise take half an hour during an uncongested situation might as well take 1.5 hours, right? That's a manifestation of the performance. Higher the demand, more is the strain on the performance of the system, on the supply of the system, right? Travel speeds and so on. Not just, in terms of travel times and speeds, reliability also starts getting influenced, right? The more congestion, the lower is reliability in the form of greater variability of travel times, right? I remember some of our colleagues and students were looking at data from BMTC, right, of bus travel times on the outer ring road from, I believe, 34 kilometers stretch from Hebbal to Central Silk Board, or maybe from Hebbal to, yeah, Central Silk Board. The travel times ranged anywhere from about 45 minutes during off-peak times to 1 hour 50 minutes or something during peak times. It's a range, that's the range of travel times you're talking about. And when this range is, by the way, not outlier extreme travel times. This is a range with good number of data, falling at these extremes. Right, good amount of data falling at these extremes. It's not like a small thin tail, so to say. Right, so that gives an idea of the unreliability of travel times on our systems. Right, that's again because of high demand, but supply demand is not matching well, so to say. Right, and that is what leads to crowding also in our buses, and then infrastructure conditions get affected. All of these things, right? So now, what some of us try to do in the community is to build what are these called travel demand models, right? Which you can think of them as, for now, this box, which we'll try to go into a little bit, takes as inputs the city's structure, how the city is laid out spatially, its land use, all the things I talked about, city's demographics, the population, employment, economics, right? And then the transport characteristics, transport systems characteristics, right? Such as what modes are out there, how easy it is to travel, how much time does it take, how much cost does it take, how reliable it is between every point in the city to every other point in the city by every mode at different times in the day, right? And then taking all of these as inputs, if we are able to model and provide as outputs these performance measures of the system, how much different modes are used, what will be the mode share, for example. If I run an extra metro, if I build an extra metro line and then provide bus connectivity to the metro line at all locations, will that lead to greater share of public transit mode and hence reduced usage of personal vehicles and hence reduced congestion, right? So such outputs help us. And then the resulting traffic flows, congestion, speeds, travel speeds, times, and all of that. These metrics, right, if you are able to predict these metrics under different scenarios. One scenario I just described, right? Add more transit supply in the city. Another scenario could be build more roads. Another scenario could be, change the land use in a way that people can travel within their locality, so to say, as opposed to having to travel too far. Right? All of these scenarios, you run the models for different scenarios and get these outputs. Then you use this information for a lot of applications. Hopefully to improve mobility in the city, hopefully to reduce consumption of energy, of travel, and hopefully to improve air quality and so on. Right? So we'll go through some reasons why we need to do it. I just mentioned, right, to improve mobility and so on. These are some reasons. Generally, what we do is we try to forecast the spatial distribution of travel, the temporal distribution of travel, and the modal distribution of travel. Meaning, where does travel happen, from where to where in the city, when in the city does the travel happen, by what modes. If we are able to get at least these three dimensions of travel in the city, at least these three dimensions, preferably more, maybe the social demographic dimension also, what type of people travel by what modes and so on, right? Then we can use these models as tools to help us, sort of evaluate various projects, various solutions we are considering, so that we don't have to, implement solutions and implement large-scale projects or even small-scale projects, right? Just based on hunch or just based on hope that things will work out. These models will provide guidance and information to help us evaluate which one might work better, which strategy might you want to modify in a certain way. For example, where do you want to run more buses as feeders to metro system? How many buses? What frequency? All these details matter, right? So we can ask questions about these details to see which particular scenario is more beneficial versus which scenario is not as much beneficial, right? And hence, hopefully move toward a more objective approach toward decision making in our transport systems in our cities, right? So some questions are, for example, if buses and metro change their fares, increase their fares. Recently there was a news about increasing fares, right? What happens to ridership and revenue? Of course, they have to generate revenue for them to sustain financially. At the same time, they also have to serve the society in terms of providing for different types of people and at different locations in the city, right? Expand metro network and provide connectivity, multimodal, or bus priority lanes. Other questions are parking regulations, congestion pricing, price vehicles, especially personal vehicles if they are single occupant vehicles and so on, right? Or mixed use developments, land use densification, pedestrian friendly developments and so on. All of these are various scenarios, right? We can ask questions about these scenarios. How will travel change? How will cities' transport systems look like under these scenarios, right? So in this context, so we are building some of these models for Bangalore in collaboration with the Directorate of Urban Land Transport, Karnataka's Directorate of Urban Land Transport, and thanks to also a company, Bosch Limited, who's helping us build some of these software tools under some of the guidance that we're providing them, right? I'm going to talk about some examples, applications of these, which are going into a lot of details of these models. But before talking about the applications, right, I want to highlight the importance of building, analyzing, managing and modeling multimodal transit systems. Multimodality is very, very important. I'll discuss why. So as our cities grow, right, generally the growth is outward, right? For example, locations like Sajapur area and so on, they have grown quite a lot, right? And cities seems to grow further and further. And it's not the case only with Bangalore, many other cities, right? That makes it very difficult for public transit systems to serve the city that is very sprawling, right? Transit systems serve very well on high dense corridors as opposed to sprawling cities, because buses then have to, provide coverage for a larger area and potentially for smaller ridership, as opposed to high dense corridors where they can provide mass transit capacity, right? High capacity, large number of people can be accommodated and so on. When cities sprawl out, although buses can accommodate or metro can accommodate large number of people, not many people come from various places and they have to serve many more miles of supply for much less of demand per supply, so to say. Right, that makes it difficult for them to provide well as sustain financially, so to say. And that's what makes it very important to provide first and last mile connectivity. Right? I remember the metro is I believe the purple line, right, which was expanded from Whitefield to Whitefield and further. Right? Before that, there was a small stretch that was not connected. That small stretch, there were a lot of buses running. Imagine if there are no buses. If there were no buses, then people would not have used that line. Right? So the lack of first and last mile connectivity options for transit modes makes it more difficult for transit to serve in sprawling cities. Right? And that's what leads to decrease in mode share of transit modes. To show you some data, here is what the mode share that was reported by reporter Philip in a news article, the BMTC ridership, right? Back from 2015 when BMTC was thriving and actually doing well and making profits, all the way to, a couple of years ago, ridership has been consistently decreasing. Various reasons, right? Increasing affluency in the city, increasing personal vehicle ownership and so on, right? And also these issues of cities spreading out and not sufficient last and first mile connectivity and all that. And of course, around this time, COVID also has played a role, obviously. But suffice it to say, ridership has been declining until recently, after this scheme of women being able to travel for free in buses has sort of attracted greater ridership now, right? That part we have not shown in the data, okay? But the whole idea is that lack of reliable first and last mile connectivity and the difficulty of transit systems to provide coverage in sprawling cities is what makes it difficult for transit systems in our cities. Right. This is where many cities in the world are focusing on providing multimodal transit systems as opposed to just focusing on a single mode and worrying only about that mode. Right. So the multimodal transit systems, they not only worry about, let's say, the stretch that transit mode provides, but also they think about the first mile connectivity, the last mile connectivity, and then they think about integration of the routes, integration of the information systems, potential integration of the fare or pricing or payments and so on. All of these things, integration of the infrastructure, all of these things, right? It's important to do so because actually every transit trip is multimodal by nature, right? Because it's very rare that transit takes us from door to door, from the door of our origin to the door of the destination, right? It's rare that bus or metro comes to our doorstep and then it takes to the doorstep of the destination, right? It's invariably we'll have a first mile leg and a last mile leg. How long is the first mile leg? How easy is the first mile leg? And how long and how easy is the last mile leg is what determines whether we take transit or not. Data consistently shows that the farther the first mile or the bus nearest transit stop is from home, the lower is the likelihood of people taking transit. Right. It's in this context that there's a lot of emphasis now on improving the access or connectivity to transit systems, because we now have understood that transit systems alone cannot function well. We have to have this connectivity, and also even the transit part, right? Potentially they could be multimodal, bus and metro, for example, right? Bus and metro. To give you an idea of how much multimodal travel in Bangalore is, some of the data that we collected, this was back in 2023 and partly 2022, shows that at least 30% of metro travelers, people who are traveling in the metro system in the city, have used bus on that same trip. It could be either to connect to the metro system or to go from the destination metro stop to their destination. Right? Or at that time, there was this small stretch of the buses running between the Bayapanhalli and the next station of the Purple Line. That also could have been a reason. But suffice it to say, a lot of people who use metro seem to be also using bus on the same trip. Right? So if buses weren't there in the city, or if buses were not used to provide connectivity to metro, then metro would not see so much of uptick in ridership. And people would not be able to use metro as much. Right? So that hopefully conveys the importance of multimodal transit systems and the need to support those systems and the need to bring multimodality as much more possible. And just to give you an idea, the variety of modes that we in Bangalore use. Of course, walk and bicycle to small extent. And then personal vehicles, motorized modes, own two-wheeler, own car, auto rickshaw, all these app-based modes, Ola, Uber, two-wheeler, four-wheeler, sometimes office vehicle, sometimes rented car or vehicle pool and so on. Majority is around here, particularly two-wheelers and then other vehicles. When it comes to transit systems, right? Metro, bus, and as I said, bus plus metro is also a dominant mode in the city within transit systems. And then to these systems, people use so many variety of modes to connect. Of course, for buses, majority, 90% connect with walk, bus stops. But when it comes to metro, a lot of them use other modes also, auto rickshaw, Ola, Uber, and so on and so forth. Again, highlighting the need for supporting multimodal travel, which will hopefully increase the use of transit systems and hence help decrease to some extent some of these other problems like congestion and so on. Right? And we use some of these models to run some policy scenarios. Right? I'll describe the policy scenario here. Here was the base case. Base case meaning the current scenario of about some 2,500 travelers that we surveyed, and we asked about their travel modes that they use for their commute. Of those 2,500 people, 5% were using metro. 27% were using bus, right? Or 27.7%. Bus plus metro, 2.6%. Okay, and then many other modes were used, personal vehicles and so on, right? Particularly two-wheelers and all of that. This was the current scenario. Then we asked a hypothetical question. What if metro is expanded? Again, not necessarily door to door, that is impossible. Metro is expanded such that all commuters in the city have metro available within 4 kilometers from their O or D, from their origin or destination, right? And then bus and bus plus metro modes are also available within 2.5 kilometers. Because from what we noticed from the data, people are willing to travel longer to connect to metro stations as opposed to bus stops, right? So we sort of posed this question to the model, and we asked the model, what would be the resulting mode shares of travel, right? So this obviously provides greater connectivity than the current situation is. Although one might say, I need connectivity to within 1 kilometer to metro and all of that. That would be nice, but not easy to achieve, right? Within 4 kilometers, we have connectivity with these access modes, the auto rickshaw and other access modes. Likewise, egress also, the last mile in also. In such hypothetical scenario, what we learned from the model was that metro mode share increases to 26%, right? Whereas bus plus metro mode share also increases to 12%, 12.5%. On the other hand, bus mode share goes down a bit. That's because now with metro being more accessible, bus might take a bit of a hit. But together, right? Together, metro and bus, whether it's in this form or in this form or in this form, together, the total transit mode share increases from the 35% in the base case to 57% in the policy case. That's what we've learned, at least from the models, so to say. And this increase comes from about 34% of the current personal vehicle users seem to be shifting to transit modes because of better connectivity now. And what we learned was expanding transit services spatially, not just by building more and more, right? But providing the last and first mile connectivity, right? Seems to be the most effective way of increasing transit share. On the other hand, reducing travel costs and travel times of access modes, egress modes didn't seem to matter much. It's get the connectivity first, and then worry about making the connectivity better in terms of lower travel times, lower travel costs and all that. Getting the connectivity first is the most important, so to say. Other example I'll give is, see, mobility has impact on air quality, right? So this was work by a former PhD student, Shashikant Gurram, who worked with a former colleague, Professor Amy Stewart, who is an air quality modeler, air quality expert. And then he also worked with me on modeling mobility. So what he asked was, can we understand how much of this mobility and travel demand and travel behavior has impact on exposures to pollutants? Mobility is what leads to emissions to a good extent, right? Of course, there are other sources of emissions, such as industry and so on. But mobility also is a major source of emissions, transportation, right? So what he did was, he tried to model the travel demand, and then this is what he did for a city called Tampa in Florida. Each panel here shows the time people spend at different locations in the city. For example, the darker a particular zone in the city is, the more time was spent by more people there. It's a person hours, right? Ranging from 12 in the morning to 1 a.m., 2 a.m., 3 a.m., 4 a.m., 5 a.m., 6 a.m., all the way for each 1 hour in the day. right? So effectively what he was looking at was the spatial temporal pattern of how much time people spend where in the city, based on where they live, based on where they travel to for their activities in the city, right? Of course, their travel brings congestion, pollution, and all those things, in addition to the pollution from other sources such as industry and all of that. And that's what he modeled here. What's on the left side? The left side panels for each 2 hours in the day, 3 to 5 a.m., 5 to 7 a.m. and so on, are traffic volumes on the network. Traffic volumes on the network, right? For example, in the evening, this is a major highway of the city, and here is another major highway of the city. This part is called malfunction junction. Two major highways intersect, it's most of the times congested. Then he was able to pick that up from the models, right, in the evening time. Similarly, in the morning time, right? What's on the right side is travel speeds, right? The lower the travel speed, the more red is the picture, right? The higher the travel speed, the more green is the picture, so to say. Now, based on travel speeds and the amount of traffic moving, the emissions depend, right? How much nitrogen oxides, for example, are emitted depends on amount of traffic and travel speeds, isn't it? Right? So he also derived those emissions, and those emissions, based on atmospheric chemistry, meteorology and all of that, turn into some pollutant forms in the environment, in the ambient environment that we all live in and travel, right? So he got those concentrations of pollutants from all of this, right? And he sort of overlaid the concentrations of pollutants on top of the amount of time people spend at each part in the city, at each time in the day, right? The concentrations of pollutions also was modeled for each part in the city at each time in the day. And this animation shows, right, the pollution concentrations of nitrogen oxides, NOx, right? And as you can see, all these lines are road networks, roads. Most of the nitrogen oxides are pollutant concentrations are around the roads, because NOx, major source of NOx, nitrogen oxides, are vehicular pollution, right, are around the roads at different times in the day. 1 p.m., 2 p.m., 3 p.m., 4, 5. As you go to the evening peak, you see greater pollutant concentration. And you see greater pollutant concentration also in the evening peak, right? This is morning. And in the evening peak, you see greater pollutant concentrations around these major roads and around these major intersections, right? And then he overlaid where people live and travel within this whole polluted environment, right? And then he sort of estimated exposures of people to the pollutants, to the NOx pollutants, right? And then he asked some interesting questions. Who pollutes more and who is exposed more? Sorry? As one would expect, and it's good to see that in these analysis, that below poverty populations seem to pollute less, because they don't travel as much, they travel on buses, right? They travel less distances, and then they don't live farther from the city. They live near the city. The more affluent people live farther from the city, suburbs, they, in their large houses, large yards and so on. So they pollute less. But since they live near these areas, right, where there's a lot of pollutants, they are exposed the most. When it comes to higher income population, they pollute more, but they are exposed the least. The differences were striking, the quantification of the differences was striking to us. And another question he asked, what if I run more buses? Let me run just more buses, right? That didn't seem to make an effect. In fact, that seemed to work the other way around. These more diesel buses did not attract many people to them. And these diesel buses, guzzling gas and polluting, created more pollution and more concentration and all that. What seemed to help though is, you run more buses but make the city more compact, bring people to more compact neighborhoods. That's what seemed to attract greater usage of transit and hence less pollution. And more people using the buses and hence per capita pollution was less. Right? And of course, he also asked a question, what if I use clean vehicles, CNG and so on, in the place of diesel? That obviously helped reduce the pollution and exposure. Right? So hopefully this gives an idea of the types of questions one can ask and provide information to decision makers using these tools. Right? Here is another application. This was in Dallas, Fort Worth. Again, a whole team led by Professor Chandra Bhatt, who at the University of Texas, Austin. I was there for some time during my PhD time. All these colleagues helped us. Again, I won't go into the detail, but here's an idea of the 4 a.m., 5 a.m., 6 a.m., how the population density is changing. Right? Dallas is this side, Fort Worth is this side. As you can see, population density in the night is where the residences are, suburbs and so on. In the day, during the peak hours, it moves toward the city center. And then it goes back in the night. Right? Some of this also can be used for evacuation planning, in addition to the type of pollution analysis and all of that I was talking about. Right? So, with that, what I'll do is, I'll skip this. If there are questions, I'm happy to come back. I'll talk about another application. So we talked about this multimodal connectivity, right? Who provides connectivity to bus stops and metro stations? Yeah, buses can provide connectivity, but can anybody else provide connectivity? What other modes can provide connectivity? Auto rickshaw, maybe Ola, Uber. But what's in it for them? Why would they do it? See, at the end of the day, they are businesses. They have to make profit. It has to work out for them. It has to make business sense for them. Right? By providing connectivity, let's say if I'm an auto driver, if I provide connectivity to the bus stop, wouldn't I feel like I'm losing the business I would get by, from taking this person from the person's origin to the person's destination? Let's say if I have to take him to the airport. Why not I use my cab directly to take him to the airport? I earn more than taking him to the nearest bus stop, maybe Makery Circle, and then leaving him at the bus stop. What's in it for me? As a mobility service provider, ride-hailing service, or this mobility as a service provider, right? So we asked that question, right? If these ride-hailing services, which have to some extent disrupted travel in cities, at least for a segment of the society, right? They provide as and when needed door-to-door connectivity, and that's what sort of increased their usage, at least in one segment of the society, right? Who can afford those, isn't it? But then public transit systems can't do that. That's why they suffer. Can they come together? Can they come together to bring the best of the both, right? While these agile, as and when needed ride-hailing services provide the last and first mile connectivity, in addition to providing the direct service that they would otherwise provide. And transit systems provide this mass transit capacity at lower prices, right? Than if one would take their own vehicle or a cab directly from their origin to destination, right? So can we bring the best of the both and create a win-win situation, right? Without cannibalizing into the market shares and revenue of either transit or these mobility as a service providers or ride-hailing services, right? And also increase profits for both entities. And can we reduce congestion and benefit travelers, right? We asked this question, right? Now this sort of becomes a game theoretic question where transit is trying to maximize its objectives. Objectives could be make profit or provide to the society. It could be a combination of profit and social objectives. And these ride-hailing services need to make profit and increase their profit. So they are trying to maximize their own objectives. And they set prices, they make their decisions to collaborate or not, and so on. While they do so, transit, for example, is trying to optimize what it's trying to optimize. Profits or some social goals. Ride-hailing services are then trying to optimize their profit. While they do so, travelers make their choice whether to travel or not, where to travel to, by what mode to travel to, right? Would they travel by only transit or only the ride-hailing modes or their personal vehicles or a combination? Now there is a collaborative mode, right? Where ride-hailing provides last and first mile, transit provides the line haul, right? So we asked this question for a hypothetical setting of IISc to airport, right? Where ride-hailing services provide the connectivity from IISc to Makery Circle, and then from Makery Circle there is buses to the airport. Of course, people can also travel directly from IISc to airport using their own vehicles, personal vehicles, or using Olas and Ubers and so on, direct service, right? What we learned was that it seems that in most situations, as long as the drivers don't violate the conditions that they drop and then they pick up a passenger to the airport and so on, as long as they don't do that, right? It seems to be a win-win for transit and ride-hailing services, right? Because many people might sort of give up using their personal vehicles to go to the airport. They use this collaborative mode that they have to go to the Makery Circle and then take a bus, right? So both bus system and ride-hailing service seems to be gaining in terms of more people, more increasing the pie of the market share for them and hence revenues. And in doing so, ride-hailing service, their vehicles are more utilized better instead of getting stuck in congestion. Because as more people use buses, congestion reduces, so traffic flow is more smoother, so their vehicle utilization increases. And therefore, travelers are also benefiting because now travel times are lower, less congestion, and also they have a mode that is a combination now of these ride-hailing and transit combination, which is lower in price to travel by than if they travel by their own vehicle or ride-hailing service directly, right? So suffice it to say that it does help to study travel behavior and model travel demand, and then use these approaches, if not exactly these, but the scientific approaches, so to say, to forecast the spatial, temporal, modal distribution of travel demand in cities, and to use these toward more objective ways of decision making in the transport systems in the cities, right? Hopefully that's a message that is conveyed today without worrying about the details, that it does benefit to study travel behavior, model travel demand, and use that actually to make decisions in the city. That's a message that I'm hoping to convey. With that, thank you for all your time and happy to discuss.